In this lesson, we will determine whether a relation is a function, and we'll also find function values. So first of all, what is a function? Well, it's a relation in which each element of the domain, which remember is x, is paired with exactly one element of the range, remember, which is y. So in order to be a function, it has to be 1 to 1, which means you have one x for every one y. So this right here is a function. This is yes, because this domain pairs with this range, this domain pairs with this range, this pairs with this range, which is okay. That is totally fine. You can have more than one x have the same output. That is okay. And 4 pairs with 9. So this yes is a function. This is a no. This is not a function. This domain 1 gets a 4 out, but it also got a negative 4 out. And that is not possible to be a function. You have to have one output for every one input, and this is one input with two different outputs. If I drew the map for this, this would be a 1 in the x. My y, I would have a 4 and a negative 4, and I would have one pairing with two different outputs. That's not okay. This is a 1 to 2. It has to be 1 to 1. This is a 1 to 1, this is a 1 to 1. So this is a yes, this is a no. So you'll have to look at some different relations and figure out if they're functions or not. A discrete function is a function of points that are not connected. So discrete are things that you cannot connect. Continuous function is a function that can be graphed with a line or a smooth curve. Examples of discrete functions would be like t-shirts. All right, I can buy one t-shirt, I could buy 2 t-shirts. Can I buy half a t-shirt? No. You could take a whole t-shirt and rip it in half, but you cannot connect 1 to 1 here because there are points that are not connected. T-shirts is an example of things that won't be connected. A continuous function would be something that would be a smooth curve, like money. Money can increase by the penny, up and up and up and up and up, and it can be connected because you could have half a penny. An ice sculpting competition, each sculpture's height was measured to make sure that it is within regulated height range of 0 to 6 feet. So the measurements were as follows. Team 1 had 4 feet. Team 2 had 4.5 feet. Team 3 had 3.2 feet. Team 4 had 5.1 feet, and Team 5 had 4.8 feet. So this is our table. Our domain, or x values, are 1, 2, 3, 4, and 5. Our range, or y values, are 3.2, 4, 4.5, 4.8, and 5.1. Remember, we have to do them in order, numerical order. So then we will graph. 1 is at 4. 2 is at 4.5, let's say that's here. 3 is at 3.2, which we'll say is down here. 4 is at 5.1, which we'll say is about right here. And 5 is at 4.8, which we'll say about right here. So we have to decide, can we connect these or not? These are team members. If I have half a team, is that something completely different? No. If I have half a team right here, they're still going to have to compete as one whole team. So I guess what I'm saying here is you can't have halves, you can't have fractions here because you have single teams. Even if you only have 2 members in your team, that's still going to be one whole team. So this is what we would call discrete because I can't connect it because I can't have the fractions, those parts in between. And if you have questions about that, you can definitely ask me. The vertical line test. If any vertical line passes through no more than one point of the graph at a relation, it is a function. So I'm going to use red to do our vertical line test. And we do a vertical line here. And I see that this intersects here and here. So this is a no. This is not a function because it does not pass the vertical line test. It crosses in more than one point. This right here, this crosses at 1 point. 1, 1. This is a yes. This is a function because it passes the vertical line test. Every vertical line that I could draw would only intersect this graph in 1 point. Here, 1, 1, 1. This is 1. This is an open circle, which means it does not touch. 1, 1, 1, this is a yes. It passes the vertical line test. So you will have some functions that you have to check and see if they are truly functions or not by passing the vertical line test. Now we have to determine whether this is a function. We don't really know how to graph these yet, so we're just going to make an xy table. And let's try 0, negative 1, and 1 for your x's. So 0 would be negative 3 times 0. 0 plus y equals 8, so this would have to be 8. Negative 1 would be negative 3 times negative 1, which is 3, plus y equals 8. So y would have to be 5 here. And 1 would be negative 3 plus y equals 8. So this would have to be 11. So 0, 8 is here, negative 1, 5 is here, and 1, 11 is here, just a little bit off. If you'll notice, this is what we call a linear function, so this can make a line, and we could keep trying points to make it a line, and I'll give you a place on your calculator to do that if you'd like. So this makes a straight line. Does it pass the vertical line test? You bet. So this is yes, a function. And I'll give you a hint now. Every linear function is a yes. If it ever makes a line, it's a yes, because that's called a linear function. So it's yes. All right. So a function can be represented in 4 ways. A table, which we call an XY table. A map, which you've been doing some work with, looks something like this, and you connect the points. An equation, which was just like what we did here, 2x plus y equals 10. That's an example of an equation. Or a graph, where you actually have a physical x and y axis, and you have points on the grid. So you can have a function in any of those 4 ways. Function notation is a way to name a function that is defined by an equation. In function notation, the equation y equals 3x minus 8 is written as f of x equals 3x minus 8. Nothing has changed. This y is now f of x, but it still means y, okay? It's just function notation. A nonlinear function is a function with a graph that is not a straight line. So it might be a parabola like this. We'll be working with those a lot this year. So let's use function notation. F of x is equal to negative 4x plus 7, and I need to find the value when f is 2, f of 2. So what we do is we just plug in f of 2. Every place that I saw an x, I now put a 2. So negative 4 times 2 plus 7, that would be negative 8 plus 7, which would be negative 1. So f of 2 is negative 1. Let's try this one. F of negative 3 plus 1. So f of negative 3 plus 1 means I'm going to put this, every time I see an x, I'm going to put a negative 3. And then this plus 1 means you're going to add 1 on the end. So you have negative 4 times negative 3, which is positive 12, plus 7 plus 1. 12 plus 7 is 19, plus 1 equals 20. So f of negative 3 plus 1 equals 20. Here is h of t is negative 16t squared plus 68t plus 2, and we want to find h of 4. So every place I see a t, I'm going to put a 4. So negative 16, 4 squared, plus 68 times 4, plus 2. So we're going to take 4 squared, negative 16, 4 squared is 16, plus 68 times 4, plus 2, and continue it on. And I'll have you answer this in your notes. When I have a 2 times h of g, this is going to be the same as h of t, but you put a g every place there is a t. So I have 2 groups of h of g. So it's negative 16g squared plus 68g plus 2. I just put a g every place I put a t. And then what we'll do is we'll distribute that 2, and I'll have you answer this in your notes as well.